We continue where we left off yesterday on the monomials thing. We're going to deal more with the powers now. So as a little warm-up, I kind of want you to do and write down some of these. You can pause and write these down. You can just kind of go as we go. But the first one is just negative 2 to the third power. I want you to think about that as negative 2 times negative 2 times negative 2, which gives us not positive 8, but actually negative 8. A negative number or a negative number multiplied by itself an odd number of times will still be negative. Negative 3 to the fourth power is really negative 3 times negative 3 times negative 3 times negative 3, which gives us positive, because we have 4 negatives, positive 81. Negative a to the sixth power is really negative a, negative a, negative a, negative a, negative a. Well, I'm going to kind of erase all those, because the negative to the sixth, that's really negative 1 to the sixth power, and then a to the sixth power, which is just a to the sixth power. And I want you to think about that negative would go away, whereas in number 4, that negative would stay there because I'm raising it to the fifth power. And if I multiply a negative by itself 5 times, I'm going to keep that. And that b to the fifth power is just going to be b to the fifth power. This one I am going to write out because I want you to think about this as negative b times negative b times negative b times negative b times negative b, and see what happens. We still have a negative, but then b to the fifth power. And that's actually considered to be more simplified than this thing right there, because you've dropped the parentheses and you're now focused entirely on the base exponent part. You know the number is going to end up being the opposite. You got that negative symbol there. For number 5, we kind of look at what the question mark would be. What would I have to multiply by 7 to the fifth power to get to 7 to the eighth? That would have to be 3. 10 and question mark to get to 16. That would have to be, question mark would have to be 6 there. For number 7, 2 to the fourth times x to the third times 2 to the question mark would get me 2 to the ninth. Notice how I'm completely ignoring the x's because I already have an x to the third, an x, and an x to the fourth. So I don't even need to worry about those. I'm just going to look at the 2's. So 2 to the fourth times 2 to the what is 2 to the ninth. That would have to be 2 to the fifth power. So question mark would be 5. And then for number 8, x to the 5 times 2 is equal to 5 plus what? Well, that should kind of be obvious. I could kind of get it right there. 5 times 2 is equal to 5 plus what? That would have to be itself. That question mark would have to be 5, because 5 times 2 is 10, and so is 5 plus 5. But the part I want you to see is that it's the same thing as x to the fifth times x to the fifth. And that's what we're going to kind of get to. So as we move in, I'm going to give you 4 more here. If I simplify these, this is m to the third times m to the third times m to the third times m to the third. And that ends up being 3 plus 3 plus 3 plus 3. Well, that's 4 times 3, or 12. And we're going to be practicing skipping directly from here to here. This is x to the second 5 times, which is the same thing as x to the 10th. This right here is, hang on just a second. Aha, I forgot a 5. That was right here. So this inner part is negative b to the fourth power. That negative to the fourth is a positive, so this is just going to be b to the fourth power. And then I have all that to the fifth power. And I'm not going to write this 5 times. We're just going to make that b to the 20th, because I know that 5 fours gives me 20. And lastly, this one I do want you to write out. 2 to y, 2 times y, 2 times y, 2 times y, and 2 times y. And that's all times each other. So 2 2's is 2 to the fourth power, and 4 2's, and 4 y's is y to the fourth power. And that gives me 16 y to the fourth. So the rule we're going to say is for positive m and n, a to the m to the nth power is equal to a to the m times n. And that's a dot in between those. And the second one is for positive m, ab to the m power, a times b to the m power, is equal to a to the m times b to the m. don't think about that as distributing because you're going to throw yourself off. But for number 5, I'm going to show you a very specific way I want you guys to worry about this one. What I want you to do is, in some ways I'm going to call this, I don't want to call this anything. In some ways we're going to look at this negative and we're going to call that another base. I'm really going to rewrite the problem as negative 1 times 4 times m times n to the third power. And then I'm going to carry that 3 to each of the different bases because these are all part of the base. And they all have an exponent of 3. And then I'm going to simplify the different parts. Negative 1 to the third is negative. 4 to the third is 64. M to the third, n to the third. And that's a simplified solution. For number 6, if I do it like that, I'm going to have negative 1 to the 5th, 2 to the 5th, and k squared to the 5th. And then simplifying that, we've got a negative 2 to the 5th is 32, and k squared to the 5th. This is raising exponents to other exponents. I'm going to write that off to the side. When I raise exponents to other exponents, you multiply the exponents. So that's k to the 10th. Let's see where we are. And I'm going to circle that. Let's go to number 7. This is a little different. The negative 2 is not part of the base. That's just going to chill out and not be changed. But the k squared to the 5th is going to become k to the 10th. And I want you to compare number 6 and number 7. They're very different when the 2 is not part of the base. Number 8, I'm going to have to raise all this to the 4th power first. So 2 to the 4th, x squared to the 4th, which is x to the 8th, and y to the 3rd to the 4th, which is y to the 12th. And that's going to be times the negative 1 to the 2nd power is positive, x to the 2nd, y to the 4th. Those parentheses don't really matter. We're going to go off what we did yesterday. 2 to the 4th is 16. X to the 8th and x to the 2nd. When we multiply the same base, I'm going to write that again. Multiply same base means we add the exponent. X to the 8th times x to the 2nd is x to the 10th. And then I have y to the 16th. Number 9, we have 1/10 to the 3rd power. I'm going to write that like this. X to the 6th, sorry, x to the 9th. When we raise exponents out of exponents, I almost messed that up. And y to the 3rd. I'm going to bring that down just a little bit. And then I'm going to take this. I still have a 10 to the 4th and a y to the 4th. And notice how you just kind of completely drop those parentheses. They don't really matter. Well, one trick about the 10 to the 3rd power, I'm going to actually make this 1 to the 3rd over 10 to the 3rd. Well, 1 to the 3rd is just 1, and 10 to the 3rd times 10 to the 4th. This can actually be very easy if you know how to deal with that, but I'm going to leave it here for now. X to the 9th and x to the, well, just leave the x to the 9th, and then I have y to the 3rd and y to the 4th, but I have to take care of that to make it y to the 7th. So, one way to deal with the 10 to the 4th over 10 to the 3rd is just to kind of write them off like this. And if I divide those, I just get 10. Another way is that 10 to the 4th over 10 to the 3rd is the same thing as 10 to the 4 minus 3. And we'll kind of get there. So whichever way you need to do to figure out that this is really the number 10, go ahead and do that. 10, x to the 9th, y to the 7th. Number 10, we got 2 to the 3rd, x to the 3rd, x to the 2nd, y to the 2nd, plus, I'm just carrying these all through. And then we have a negative to the 3rd power, so that negative is going to stay. It's a negative 1. And then an x to the 3rd. Now I'm going to spend a little bit of just one more step cleaning this up. 8, this would be x to the 5th, then y squared. And then I have a negative in 2 squares. This would be minus 4, x to the 5th, and then y squared. And those are like terms. So 8 minus 4 is 4, and I have 4x to the 5th, y to the 2nd. Number 11, We're going to try this without writing 2 to the third. So I know 2 to the third is 8, and x to the third is x to the third. Then I have another x squared, y squared. Then I have a times. 2 to the second is 4, x to the second, y to the second. And then I have a negative x to the third. So there's a big difference between this one and the previous one, and I hope you can spot it. In the previous one, it was a plus sign, and I had to deal with the left and the right side of that plus sign. Here, it's a times. I can actually even erase that and just kind of keep this all in one line and focus my attention on the 8, the 4, and the negative 1 to multiply them all together to give me negative 32. Then the x's, 3 plus 2 plus 2 plus 3 is x to the 10th. And then the y's, we have y to the 4th. Number 12, this is kind of like the one in the previous one where it's all mostly variables. But if I raise exponents to other exponents, raise exponent to exponent means that we multiply the exponents. So that's a to the 3 times x is 3x. Not much work there. We can see in number 13 how this is going to work. This is going to be 4 to the third power is 64, and x to the n to the third power is x to the 3n. Multiply the exponents. And this would be x to the 5n. And now I'm going to follow the rule that when I have the same base and I'm multiplying with the same base, we add the exponents. 64, x to the 3n plus 5n, or 64x to the 8n. Raise t to the m times n times a 3, and then times a t to the m times n, or actually nm. But remember, nm is the same as mn. So the 3 is going to chill out in front. Can't really do much with that. But this and this, they can add, multiply base, add exponents. That same rule from over there. So I have t to the 2mn. Because when I add mn plus mn, I get 2mn. Number 15, got 3 squared, c squared, m to the 6th. We can treat this as negative 3 cubed, or I can treat that as a negative cubed, and then a 3 cubed, and then a c squared, and an m to the 4th. Oh, kidding, not c squared, c to the 6th power, and m to the 12th. Carrying that through. Okay, so I got 9 times 27. 9 times 27 is 243, and it's a negative, because that negative 1. C to the 2nd times c to the 6th is c to the 8th, and m to the 6th times m to the 12th is m to the 18th. Number 16, 1/2 squared is 1/4. Y to the 3rd squared is y to the 6th. 2 to the 5th is 32, and y to the 5th is y to the 5th. 1/4 of 32 is 32 divided by 4, and y to the 6th times y to the 5th is y to the 11th. I believe that's the last one. 3 cubed, a to the 6th, b to the 3rd, then 2, a to the 3rd, b. And all I'm going to do here is the same thing we've been doing. 3 cubed is 27, and times 2 is 54. A to the 6th times a to the 3rd is a to the 9th, and then b to the 4th.